Welcome back. We're going to begin our work on video 3 from Unit 3, continuing our look at different ways, different algorithms for addition. This is a good time as any for me to point out, I think I don't want you to I want you to understand that the methods that we're going to look at here are give us options as teachers. I think what we do when we teach is we often throw out what we think will be our easiest way for kids to understand. And luckily, most times the bulk of our kids probably pick it up. They get it. The problem we have as teachers is what do we do for those kids who didn't get it with what you thought was plan A? Do you have a plan B? Do you have something that you can throw out there maybe as a means of picking up those kids who struggled on the first round? And that's what I think these additional ways to look at addition and later on some other operations as well provide for us. I think they enable us to be a stronger teacher in that we've got options for the kids who maybe didn't see it on the first cycle through. All right, so let me go get a PowerPoint here we can share. Okay. All right, so we're going to go from that slide. And the first thing we're going to meet in video 3 is the idea of lattice addition. All right, so we're going to add 7,652 with 5,768. And you kind of see that I went ahead and built some little rectangular boxes with little diagonals down there underneath each of the digit columns. And that's my lattice, if you will. It's not a hard process, and for a lot of kids, it's actually pretty cool. You don't get bogged down in the carries. And if you were to think about the addition that's indicated here, there are several carries involved. And sadly, for some kids, the notion of carrying is a challenge. It's a tougher challenge. So here's what you do. I'm going to click the slide and take us to a bigger one to see. Are you going to add the 8 and the 2? And again, you could work this left to right. So if you have that kid who says, I want to do left to right like I read, you could allow that here in terms of the arithmetic. So I'm going to do 8 plus 2 and get 10. Now notice how the 10 gets written. All right, the 1 goes in the top part of that diagonal box and the 0 goes in the bottom. And then you simply go ahead and do the other additions as well. 5 and 6 for 11, 6 and 7 for 13, and 7 and 5 for 12. I should point out, if by chance you have a sum that's only a single digit, it goes in the bottom of those little divided cells. And some authors prefer or recommend that you put zeros in if you have sums that are single digits. So again, my problem is I don't have that showing up very well here. To get an answer now, you can notice that there are little diagonal setups for us. And we would now go ahead and add those diagonals. Okay, so the first one I just kind of indicated right there. There aren't many numbers in that diagonal. It looks like it's just a 0. So that sum would just be 0. On the next one, we'll add the diagonal there with 1 and 1 in it. And you guessed it, that would be 2. And then we'll add the next diagonal. It's got a 3 and a 1. That would be 4. The 2 and the 1 get us 3. And much like the first diagonal, the last one only has 1 entry. So it's a 1. And you get your answer kind of just staring at you there in pink, 13,420. And by lattice addition, we never got bogged down in the carry. The carry was kind of considered as part of the lattice method. So I like it. Certainly something you can show your kids. Again, I don't think that it takes away the addition algorithm that we perfected from elementary school. I think it's a tool. I think it's something we can use for the kids who are struggling. All right. 13,420. Here's the second example. There on the right edge, or I should say on the left edge, you see where we added 3 and 5. And we did get a single digit answer. We got 8, and there you see the 0 is filled. That's probably a good strategy. Okay, so that's just a second look. And again, make sure you have your kids understand that to get the answer, they're going to add those little diagonal entries. So you would be adding the 1 and the 3, and that's how the 4 came in. Okay. Now, the addition that you or I are using for this course doesn't contain scratch addition. And I was so intrigued by scratch addition, I decided to keep it in. So previous editions considered it. I'm going to put it in. I didn't bring it into your test situation. I just thought it was cool to show. So we're going to take a look at scratch addition. Again, remember, it's another method. It's another tool. It's something you've got in your toolbox that can make you a more effective teacher, I think. All right, so we're going to add with scratch addition. The advantage is we don't ever have to build up a big sum. And that mental arithmetic for some of our kids is a very daunting task. All right, you ready? We're going to add 58, 74, and 69. You should know that you can add from top down or bottom up. So we're going to do top down. And first thing you and I would do is we'd add 8 and 4, and we'd say 12. Now, if we were doing our traditional algorithm, then we would take the 12 and we would add the 9. And you can see what I'm saying. The numbers keep getting larger and larger. And if by chance we were adding more than 3 numbers on our stack, it could get kind of clunky. So when you do scratch addition, as soon as you get to an answer that's 2 digits, you scratch. So 8 and 4 is 12, and you guessed it, that's 2 digits. So what we do is we scratch the 4 and we record the 2 from the 12, the ones digit, if you will. Okay, and then we pick up the 2 and we add our next number, which in this case is 9. And you guessed it, that's going to be a 2-digit answer again. So again, we will scratch and we'll record the 1, which is the 1 on the 11, all right, the ones digit. There are no more numbers for us to add, so we now have, as a result of all the additions in our first column, just that 1 that we simply just wrote. So I'll record that for us. Now, what you do is you now count the number of scratches that you've made. And I don't know about you, but it looks like we've made 2. So the number of scratches, in effect, is the carry. So you're going to see I'm going to write a little 2 up there as a result of the 2 scratches that we had introduced. And now we'll start to add again. 2 and 5 are 7. That's a single digit, so there are no scratches yet. That 7 and 7 are 14. So you guessed it, there'll be a scratch on the 7. And my 4 got a little bit close. All right, that's the 4 from the 14. 4 now adds to 6, and that would be 10. And you guessed it, that's a 2-digit number. So we'll slash and we'll record a 0. Again, there are no more numbers for me to add to my 0, so I'm simply going to record my 0 as a sum. I'll count the slashes in that leftmost column. It looks again like there are 2, and that would go to start my next column, which is pretty much non-existent on this problem. So the 2 just drops all the way down, and you guessed it, our answer is 201. This one's another one. All right, you ready? 7 and 7 are 14. Yes, you're right. Scratch 4. 4 and 5 are 9. No scratch. We're holding 9. 9 and 8 are 17. Scratch 7. 7 and 2 are 9. Count the scratches. There are 2. Record the 2. 2 and 2 are 4. 4 and 3 are 7. 7 and 2 are 9. 9 and 1 is 10. So that's a 2-digit guy. So the 1 will get slashed. All right. And the 0 gets recorded from the 10. 0 plus 4 is 4. Count the scratches. In this column, it looks like there was only 1. And again, there are no other numbers in that third column. So the 1 slots on down, and my answer is 149. I like it. It's a lovely little option. It takes a while to get used to, but I think it's more options are good things. Okay, we're going to take a look at mental math and some estimation strategies. Now, it's important that we understand there's a difference in focus here. And look, I'm as guilty as any other teachers. The notion of having kids grab a calculator and be stuck with it, I think is kind of overwhelming. Certain kids are going to that's the way they're going to always have to do math. But I think if we work with young kids, we can get them to be better with mental arithmetic. And that's kind of the goal that we're having as we'd have these discussions. Okay, mental mathematics is you and I getting the exact answer, and then we'll all contrast that with some estimation kind of skills. All right, adding from the left, you and I have already done this. So we're going to add the 7 and the 5, and that's 12. All right, so in this case, that's 120 because of the place values. Then we'll add the 9 and the 4, and that's 13. And we'll add the 120 and the 13. So this process you and I have already considered. Here it's broken out a little bit more analytic going left to right. But if you wanted the kids to do it the way we did before, this is perfectly fine by my book. All right, 133. Second example, all right, we're going to add the 5 and the 3. That's 8, but it's in the 10 spot, so that's 80. We'll add the 8 and the 4, that's 12, and then we'll wrap it up by adding 80 and 12. You guessed it, 92. Breaking and bridging. All right, so what we're going to do here is we're going to take that 45 and we're going to tear it apart. We're going to convince our kids that it's easy to add 67 and 40 because it only affects the left digit. It affects the 6. It won't get that carry kind of thing going on. So breaking and bridging, what happens is the 45 gets broken up. And the first arithmetic is 67 plus 40. And you get to kids say, oh, cool, that's 107 because it was easy for me to do that arithmetic. And now you have to realize that you've only added 40. You were asked to add 45, so you have to add 5 more. So now we'll take the 107 and we'll add the 5 more to that to get us a total of 112. So we took our second number there, we broke it up, and we did a little math bridge. Second, if you like, 83, you guessed it, we'll add 20 because that's easy because it doesn't affect the right side digit. So 83 and 20 is 103. Now we still have to add the 7. We added the 20 already. So have to add the 7. So 103 plus 7, you guessed it, for 110. All right, breaking and bridging. Trading off. All right, it's what you do here is you say, well, I'm going to take the 45 and I'm going to break it apart again. Maybe it's easy for your kids to say, well, shoot, if I was adding 3 to 77, that'd be pretty sweet. I could do that, and that would get me 80 right away. So that's what you're going to do here. You're going to pull off what's easy to add, namely the 3, to get to 80. And then to realize that if you were asked to add 45, you've only added 3 so far. You'd have to add 42 more. Okay? So our last addition is 80 plus 42 for 122. It's kind of similar to breaking and bridging, except we kind of broke off the little number first. You probably want to add 4 to that 36 to get you 40. Then you're going to have to take the 4 off the 29 and say, hey, whoa, I still got to add 25 more. And 40 and 25 be 65. So these are strategies that we can use with our kids. We're going to have to write stuff on the board. We're going to have to say, how could you do this one if all you had was your brain? All right. We're going to have to provide opportunities for them. Compatible numbers, basically, I don't think we do enough here with kids. We get them into the top-down mode, and they often don't look at all the numbers. But if you're critical, and somebody says, well, shoot, it's easy to add 140 and 60. Yeah, let's do it. All right, there's 200. And if you look at it again, some kids can say, well, shoot, it's just as easy to add the 130 and the 70. Yeah, it's another 200. And then don't get them to forget the 50. All right, so the final answer on this package of arithmetic, by combining things that are relatively nice to add together, all right, is 450. So compatible numbers, the idea of adding a bunch of stuff without looking is I think something we want to discourage. Look at what's there. Are there any easy adds? Don't be proud, take them. All right, here, it's 25 plus 75 is easy. So that's what we're going to do. We're going to add the 75 to the 25, and we're going to get 100. And we're going to realize that we still have some more to add because we were asked to add 78. We've only added 75, so we still have to add 3 more to get 103. And yeah, that circled in set is the 78. We added in components, realizing that it was easy and convenient for us to add 25 and 75, and then we'll add the leftover 3 to get our total of 103. That, my friends, ends video 3 for Unit 3. I'll be back soon with video 4. See you then.